Welcome back. Now that we've got our character bases set up, we can dig into the real meat of network games in Unreal Engine using its easy-to-use property replication system and various object types made specifically for communicating information over network play. In this video, we'll learn about the game mode, game state, game instance, and player state objects in relation to network play. We'll dig into implementing the property replication on the player state, and we'll also learn about server, client, and net multicast functions for performing actions across the network. Using this knowledge, we're going to add some replicated properties to our player state, namely current health, number of coins collected, and number of death. The first thing you'll need to know when jumping into creating network games in Unreal Engine is exactly who can access and affect what data when it comes to network play. Some game objects only exist on the server, some only on the client, while some are replicated and persist across both client and server. On screen now is a small table that shows you where everything lives. As you can see from this table, the game mode exists only on the server. The game mode is then naturally responsible for handling game functions that need to be controlled by the server. For example, when a player dies, the game mode would be in charge of respawning said player, or if someone reaches the finish line in a race, the game mode would detect and replicate any game state changes necessary. Following naturally from the game mode, the game state class is in charge of keeping any game state information that would be necessary for the server and clients to be aware of. For example, the game state class will inform clients of any state changes. For example, lobby, waiting for players, running game, game over, and game restart. The game state also contains a reference to a players array, which is an array of all currently connected or idle player states. The player state class is where player-specific information necessary on server and clients resides. This is where values such as selected character, current health, coins collected, etc. will be stored. The final piece to the gameplay stack is the game instance object. The game instance exists only client-side. It exists on the server as well, but acts as a client object only, and is usually used to control application-wide state machines. For example, the game instance will be in charge of navigating menus and initializing connections before handing off control to the game mode for the server or game state for the server and client. We'll be digging into each and every one of these object types in future video, but for this one, we're going to focus on the player state and providing within them replicated properties. So with all that said, we'll move back to our Unreal editor and create a new C++ class based on player state. I named mine Platformer Player State. Once created, move over to Visual Studio where we'll add a few protected properties that we want replicated. So in our Platformer Player State.h file, we're going to add the constructor, a Platformer Player State, and a protected tag with 4 replicated properties. So uProperty, replicated, visible anywhere, blueprint read-only, category equal platformer player state, int number of coins collected, followed by uProperty, replicated, visible anywhere, blueprint read-only, category equal platformer player state, int current health. And then uProperty, replicated, visible anywhere, blueprint read-only, category equal platformer player state, int number of death. And finally, uProperty, edit defaults only, category equal player state, int max health. Notice how we've marked 3 of our uProperties with the replicated flag. This is the first, though not only step in ensuring that our properties are replicated. To complete our property replication, we need to implement a getLifetimeReplicatedProps function in our CPP file, and within it, call a macro defined in UnrealNetwork.h include file, called doRepLifetime, that tells the engine that these properties are indeed replicated. So let's do that now. In our platformerplayerstate.cpp file, we're going to add the include at the top, include UnrealNetwork.h, and within our constructor, we'll set the default values for our properties. So we're going to add number of coins collected equals 0, max health equal 3, current health equal max health, and number of death 0. After the constructor, we're going to define our getLifetimeReplicated_props function. So we're going to define void a platform or player state getLifetimeReplicatedProps, and as parameter t_array f_lifetime_property and out_lifetime_props const. And within this function, we're going to call our super getLifetimeReplicatedProps out_lifetime_props, followed by the macro I mentioned earlier, do rep_lifetime a platform or player state, current health, followed by do rep_lifetime a platform or player state, number of coins collected, and do rep_lifetime a platform or player state, number of deaths. If you were paying close attention, you'll notice that I forgot to put const at the end of my getLifetimeReplicatedProps function. I add this here now and it fixes all the build errors. This is all that's required to replicate the properties we just defined. Now, whenever the value of these properties is changed on the server, they will be replicated back to any connected clients. So this gives us a basic understanding of how to pass player data between network players, so we can implement a few interesting gameplay elements. In the next video, we'll implement a pickup system, hearts to replenish health, coins to be collected, and power-ups that will bestow the player with new abilities.